Each of the following inequalities is true for some values of x except. Before we try to wrap our head around this question, let's just pick a number for x. So if you're like most people, you'll pick x equals 2. 2 squared, 2 cubed. That's 2, 4, 8. Looks like x smaller than x squared, smaller than x cubed. So what does that mean? That means that answer choice A is true for the value of x equal to 2, which means answer choice A is not the correct answer. Now we might try another value for x. Let's try x equals 5. 5 squared, 5 cubed. Wait a minute, it's exactly the same thing. So what's going on here? Most of the time, when we're told that x is any number, we tend to think of a positive integer. If I asked you to pick a number at random, chances are pretty slim that you'll pick -1/3. And that's fine. If you are doing a problem where you're just inventing numbers to try to solve an equation or solve a word problem, that usually works perfectly well. My favorite numbers are 1, 2, 5, 10, 100 for percent problems. But for harder questions, when we're asked whether equations could be true or must be true, we need to look for exceptions. And what we need to turn to are negatives, fractions, and negative fractions. So I'll say it again so it'll stick in your mind. Negatives, fractions, negative fractions. So back to the question. We've already dealt with x equals 2, and that eliminated choice A. So what we've got left are negatives, fractions, and negative fractions. So let's look at -2. -2, -2 squared, -2 cubed. That's -2, 4, and -8. That means -8 less than -2 less than +4. So this looks like x cubed less than x less than x squared. That tells us that D is wrong. Let's look at 1/2. One half, 1/4, 1/8. Looks like that leads to x cubed smaller than x squared, smaller than x. That rules out answer choice E. Finally, with -1/2, we're going to have -1/2, 1/4, and -1/8. Putting those in order will be -1/2, smaller than -1/8, smaller than 1/4. Looks like x smaller than x cubed, smaller than x squared. And finally, that eliminates answer choice B, leaving answer choice C. Now, we've got to come up with another method of verifying why answer choice C is impossible. And to do that, I'll remind you that it's okay to divide both sides of an inequality by x squared, because x squared is always positive. So let's leave that on the screen so we can see it. If we have x squared less than x cubed, we know that because x squared is positive, we can divide both sides by x squared, and it doesn't change the direction of the inequality. That tells us x is bigger than 1. That would be if this inequality were true. X squared less than x cubed. Now, let's suppose that x cubed were less than x. So if we have x cubed less than x, we can do the same thing, divide both sides by x squared, and that gives us x is less than 1 over x, which is a contradiction of the fact that we've already deduced that x is bigger than 1. Because any number larger than 1 cannot be smaller than its reciprocal. Just to give you an example, 2 is not less than 1/2. Personally, I strongly dislike the second method. The best way to sort out these problems where you know that you have to look for exceptions is to remember your negatives, your fractions, and your negative fractions.